Today was a really hot day. Record temperature 97 degrees Fahrenheit on September 14th. It's never been that hot that late in the season. Bright sun. You wouldn't believe it was September unless you measured the angle of the sun. Here we have a washer. Now let's just pretend that this washer has been out in the hot sun. And we bring it into the lab and quickly hang it on a peg to cool off. The room temperature is, let us say, 80 degrees Fahrenheit. And when we hang the washer on the peg, let's say that the temperature of the washer is 160 degrees Fahrenheit. And then let's say that the washer cools off fairly rapidly, cooling off from 160 Fahrenheit to 140 Fahrenheit in 10 seconds. Okay, so we go from 160 down to 140 over a 10-second period. You can see that that's a negative 20 degree change in 10 seconds, negative 2 degrees per second. Between 160 and 140 seconds, we might say that something pretty close to 150 Fahrenheit is going to be associated with that precise rate of negative 2 degrees per second. And intuitively, we understand that at 160, it's going to be changing a little faster than that, and at 140, it's going to be changing a little slower than that, somewhere in the neighborhood of 150. Not exactly at 150, but pretty close. That average rate of negative 2 degrees per second that we experience between the 160 and 140 degree temperatures is going to actually occur. Now, if we draw a graph of the temperature of the washer versus clock time, temperature here, clock time here, and we express the functional dependence of large T temperature on small t clock time, implicitly measuring temperature in Fahrenheit degrees and clock time in seconds. Let this horizontal dotted line represent the temperature of the room, 80 degrees in this example, 160 degrees to start with. The temperature is going to fall, but it's going to fall more and more slowly as we get closer and closer to room temperature, because it's the excess of temperature over room temperature that drives the change of temperature. Now, let's have a name for the excess temperature. Let's call that the temperature difference. The difference between the temperature of the washer and the temperature of the room at any point is what we're going to call the temperature difference. And if we talk about a difference between two temperatures, we're not going to call that the temperature difference. We're going to call that dt or delta T, the difference of temperatures. That's a little bit confusing, but let's try to live with it for a while. And we're going to ask ourselves how the rate at which temperature changes is related to that temperature difference. Intuitively, we know that it is related. Again, how is it related?